this video. Hello everyone and welcome to the 17th video on the channel and one of the more videos on Algebra 2, of course, which is the new series right after Algebra 1. And I'm so happy to have you here. And one more thing before I go on to our answers to our previous questions, please make sure to like and subscribe for more awesome content just like this. Without further ado, let's go on to our answers to our previous questions. For our first question, the answer is x is equal to 3. And for our second and third question, the answer is the exact same. It's x is equal to 2. By the way, you should definitely go watch my last video because this is where it's coming from. The questions that were asked in the last video, these are the answers to those questions. So make sure to go watch my last video. Thank you so much. And without further ado, let's go on to the lesson. Today's lesson is about two main logarithm properties. Now, if you remember my last video, I briefly talked about exponentials and logarithms. Now, they have different properties associated with them, but today I'm going to talk about logarithm properties and the two main ones. You can see them on the board right here. Let me read them out. Logarithm base A of m plus logarithm base A of n is equal to the logarithm base A of n times n. So basically, if I have two logarithms and they have the same base and I'm adding them up, that's equal to the logarithm of the multiple, like if I multiply the two things that the logarithm is happening about. One example, if I have logarithm base, like maybe let's say 11 of 15 plus logarithm base 11 of 2, this would be logarithm base 11 of 15 times 2, which is 30. That's how it would work. The second property is kind of like the exact opposite. We're flipping everything. Instead of plus, it's minus, and instead of multiplying, you're dividing. So if I had the same example, but instead had minus, that would be logarithm base 11 of 15 over 2, instead of 15 times 2 or logarithm of 30. I think it'll be easier with a couple of examples. Our first example is logarithm base 5 of x plus logarithm base 5 of y. And we want to know what this is equal to. Now, this is really simple because if you look at the logarithm formula above in the lesson page, what we would see is logarithm base A of something, in this case is x, plus logarithm base A, which is 5, of something else. We would have to multiply these two. So the answer to this would be logarithm base 5 of x times y. This is our first example. For our second example, I have natural logarithm of 12 minus the natural logarithm of 15, and we want to know what that is equal to. What this is equal to is really simple, because ln is, remember, that's the natural logarithm, or the logarithm with the base of e, and e is the Euler's number, which is like 2.7 something something. That's how it works. And so if we wanted to do this, it would just look like the regular formula, except of logarithm base A, we would just say the natural logarithm of 12 divided by 15. But we have one more step. That if you divide both sides by 3, you get natural logarithm of 4 by 5. Or we can just say the natural logarithm of 0.8. This could also be how it works, and this could also be the logarithm shown if you wanted to do it like that. Or you could do it as 4 by 5. For our third and final example, we actually are compounding a couple things. We have logarithm base 3 of m plus logarithm base 3 of n is equal to minus logarithm base 3 of r is equal to what? This is really simple. All we have to do is take it one step at a time. If we start with this would become logarithm base 3 of m times n, okay? And then if we have minus logarithm base 3 of r, we would get the logarithm base 3 of mn divided by r. This is one example where it shows that you can stack things on top of each other. Like if I have that example shown below, with the third example, all I would have to do is take it one step at a time and go from left to right. Kind of what you do with order of operations. So those are our 3 examples. Of course, none of my videos is complete without me assigning you a couple practice problems. The first practice problem for today is logarithm base 7 x minus logarithm base 7y, and we want to know what this is equal to. Number 2, natural logarithm of 12 plus natural logarithm of 15 minus natural logarithm of 20. We want to know what this is equal to. And our third example is logarithm base 4 of 17 plus logarithm base 4 of 3 is what? One more thing, make sure that if you ever have any of these problems, like any problems that you would encounter in school, or maybe if you're in a job or if you're doing something else and you encounter these problems, make sure it has the same base, because if it doesn't have the same base, you can't apply the 2 properties shown here. Thank you so much for listening/watching, and see you in the next one. Bye-bye.